Good, my statisticians. This is Professor Sampson from PS I Love Math, back with another statistical banger. Today we're going to continue our conversation about probability by doing permutations and combinations in the calculator. So sit back, relax, grab yourself a matcha, and don't forget to like, comment, and subscribe. Okay, my statisticians, we're back talking about combinations and permutations, which we actually need to start off with factorial. When you need to count the number of ways an object can be chosen out of a group of distinct objects without replacement, that's a combination or a permutation. I'll repeat that. When you need to choose a number of ways to get objects out of a group of distinct objects without replacement, that's called a combination or permutation. But the first thing we need to do, and you might not understand it right now, just give me a couple seconds. Start with factorials, because the basis of a combination is something called the factorial. But if you think of a number and a number less than or equal to that number, the word product means what? Multiply. So you're multiplying the numbers consecutively downward. If we wanted to write some fancy smancy notation here, which is a notation that we use, what we call it is factorial, which is an explanation point. So that explanation point is called factorial. So in factorial, some number factorial, if we're writing fancy smancy, is n times n minus 1 times n minus 2 times n minus 3, and then we go all the way down till we get times 2 and then times 1. The fancy smancy look of it is. For example, if we wanted 7 factorial, that's the same thing as what? 7 times 6 times 5 times 4 times 3 times 2 times 1. That's what that means. That's what a factorial is. So let's take a look at our calculator. 7 times 6 times. So that answer is 5040. And of course, if we're talking about 30 factorial, you're not going to be typing it in that way. So let's see how we put in 7 factorial. So we're going to hit the number 7. We're going to go to the math button, and you go over to probability, because that's the section we're in. And right there, you hit number 4, and you'll see the explanation point number 4. And 7 factorial, hit enter, and that's 5040. So that's how you find a factorial in your calculator. So our answer was 5040. So we are never going to type in it 7 times 6 times 5. Just a note, just so you know, 0 factorial is equal to 1, right? That is what it is. If you put that in your calculator, you won't get 0, you won't get nothing. Don't worry about it. It just is what it is. Just like 5 to the 0 is equal to 1. That's just the rule. Do not try to outthink the rule. And why is the rule that way? The rule is the rule. So just so you know this, anytime you see this, you know that that's equal to 1. So that's a factorial. So with the factorial, we want to get back to how this relates to what we were talking about and what our topic is, which is combinations and permutations. Combinations is when you want to choose something, let's say 40 people, and you want to choose 4 to help you out. But the difference is a combination in order does not matter. In a permutation, order does matter. That's the difference between a permutation and a combination. You have to decide whether your order matters or your order doesn't matter. Now, I'm going to give you the formulas for a permutation and a combination. However, we'll be using our calculators, but if you're not my student and you're a YouTube student or a student at another university, your instructor may make you use it. So the combination of n things taken r at a time. The formula is n factorial over r factorial times n minus r factorial. A permutation of n things taken r at a time is equal to n factorial over n minus r factorial. Now, I had to memorize these. I will not have you memorize these, but these are the two formulas. That's why you had to know what factorial meant. So what is r? R is the objects being selected. N is the distinct objects, the objects themselves. So you might want to take 12, you have 12 marbles and you want to take them 3 at a time. Then you decide whether the order matters or the order doesn't matter. Then you can decide if it's a permutation or a combination. This first example I'm going to show you, I'm actually going to show you how to do it using the formula. So you've seen the formula. And then after that, I'll show you how to do it in your calculator. A teacher must choose parts for the upcoming Thanksgiving play from her class of 17 students. How many ways can she choose the parts of of Pilgrim, Native American, and Turkey. The first thing we're going to write down is the variables. So indistinct objects. So N is equal to 17 because she has 17 distinct students. R is the objects being selected. How many are we selecting? R is equal to 3. So we have our N and our R. So the question becomes, does order matter or does order not matter? Then that'll tell us whether we're doing a combination or a permutation, and it'll tell us which formula to use. Well, in this case, of course, order matters. Why does order matter? If she chooses a kid to be a Pilgrim, then they can't be a Native American or a Turkey. Since order matters, it's going to be a permutation. So the permutation formula, N things, right? So we have 17 things taken 3 at a time, and that's equal to N factorial, 17 factorial, all over N 17 minus R 3 factorial. 17 factorial, remember factorial is under math and probability number 4, divided by, now we want to put the bottom in parentheses, that was 17 minus 3, close parentheses, and then you have to go back to your factorial button, which is number 4 again. So the answer is 4080, 4080. So in your calculator, all you need to do in your calculator is determine whether it's a combination or a permutation, and then you don't have to use the formula. So let's take a look at our calculator. So we determined that the order does matter, so this is a permutation. So once we know it's a permutation, now there are 2 ways to do it depending on if you have an 84 or 83. Please comment down below and let me know if you have an 84 or 83. However, I'm going to show you how to do it on an 84 first, then I'll show you how to do it on an 80. We need to go to math if you're on an 84, and you go over to probability. Now then you have to determine whether it's a permutation or a combination. In this example, we said it was a permutation, so we're going to hit number 2, and then we can just fill in our numbers. So it's 17 things taken 3 at a time. There you go. You have 4080. Now to note that you have to determine whether it's a permutation or a combination, because if you made a mistake and said it was a combination, you would have chosen number 3. That was number 2 was permutation. Number 3 is combination. Let's say if you chose number 3, you see you get 2 different answers. So you have to choose whether it's a permutation or a combination, and then the calculator will give you the right answer. So let's get back to those 83s. If you have an 83, you have to enter the number first. So if you were going to have an 83 and it was a permutation, 17 things taken 3 at a time, you have to enter 17 first, then go to math and go to probability and go to permutations, and then hit in 3. So this next problem is the same thing, it's similar wording. Think about this. A teacher must choose parts for the upcoming Thanksgiving play from her class of 18 students. She needs a group of 4 students to serve as program attendants before the start of the play. And how many ways can this group be chosen? Now listen, before you jump on the other bandwagon, what she's asking is not for what we asked for before. She just needs 4 students to serve as a program attendant. Does the order matter? No, the order doesn't matter how you choose the program attendant. So this becomes a combination. So now that you know how to put it in, it's the combination of 18 things taken 4 at a time, which you can put in your calculator. And just to show you the formula real quick, just in case you had an instructor that needed you to do that, we would have our 18 things, and then we would have our R again, which is 4. And then we have the same thing as we had before, 18 minus 4 factorial. Again, you are not required to memorize these formulas. This just shows you that the formula will work regardless. And you pull up, since it's a combination, however you do it, if you have an 84 or a 83, I think I said 18 things taken 4 at a time, and that's 3060. So it's totally up to you. You have to remember which one it is. So these examples that I'm showing you are just showing you, trying to help you determine whether you have a permutation or a combination. After that, of course, it's easy to put it in the calculator. In how many ways can a graduate student fulfill the master's degree requirements in mathematics if 10 classes are needed from a choice of 15 classes? Does the order matter? Based on the information that you have, no, the order does not matter. So if the order doesn't matter, it's a what? It's a combination. So that's a combination of 15 things taken 10 at a time. So I'm going to leave that there. Please get the answer to the last one, put it down in the comments, and I'll let you know if you're right. The next problem is, in how many ways can a task force of 4 people be chosen from a group of 12 employees? You're looking for a task force of 4 people be chosen from a group of 12 employees. Do we have an order in which we need to worry about these? No, that's going to be another combination. 12 things taken 4 at a time. Again, pretty simple to do in me a calculator, I can do it the 83 way. I can put in 12, then go to math, go over the probability. And I said it was a combination taking 4 at a time. All right, and my answer is 495. Okay, so they're pretty easy once you determine whether you're dealing with a combination or a permutation. The Siegel family is planning their vacation. Good for the Siegel family. We don't care. Each of the 5 family members is allowed to nominate 3 places they would like to visit. If they want to visit 4 different places during the trip, in how many ways can they plan their road trip, assuming that no family member chooses the same place? So what do we think about the Siegel family here? Probably could care less about the Siegel family, right?
Oh my God!
So the issue is, do you think first, is this a permutation or a combination? Does the order matter? Actually, yes, the order matters because no family member chooses the same place. So if somebody chooses one place, then it can't be chosen at that time. So the order that the place is chosen matters. So we know that's going to be a permutation because order matters. So here we know we're going to visit 4 different places. So whatever it is going to be taken 4 at a time. So how many? Is it going to be 5 things taken 4 at a time? Well, no, because each family member is allowed to choose 3 places. So that's actually going to be 5 times 3, which is 15. So you're going to have 15 things taken 4 at a time. 15 things taken 4 at a time. Let's go to my calculator. So again, 15 things taken 4 at a time. Permutation. This time I'm going to do it using the 84 way. If you have an 83, don't forget to hit the 15 first. 15 things taken 4 at a time. And there we go. Our answer is 32,760 ways that they can get in order the places that they're going to be going. So 32,000. That's combinations and permutations and factorial all together in this video. Make sure you know how to do them. If you want more information on probability, don't forget to look at the video before this on multiplication, the other video in addition, and also your intro to probability, all the definitions. So that covers all the probability for this chapter. Thank you. This is Tessa Sampson from PS I Love Math. Don't forget to like, comment, and subscribe.
Just give it up. I'm not your girl and I never will be.